University of KwaZulu-Natal regarding the technology. The university has implemented e-learning system in the chemistry laboratory. The system is there to help students when they're performing their academic practical experiments in an absence of the demonstrator. The laboratory comprises of the visual world environment, which uses the very common tool X3-dimensional, which is used to view users in three-dimensional in e-learning system. Without the waste of time, let's go to the University of Cape Town and check on what teaching or learning approaches they've used for their direct learning and indirect learning.
Students learn effectively in Second Life by being active and interacting with other adventures. So our design goals under pedagogy are for both self-directed learning and formal teaching. In self-directed learning, the students learn by preparing, where they prepare themselves for some practical session. Secondly, the students learn by doing, where they interact with objects in the visual space, conducting a practical experiment based on what they have prepared. Lastly, students learn by reflecting, where they give us some where they give some feedback based on what they did in their practical session by writing some practical reports. The formal teaching is implemented in two different ways: group work and active learning. In active learning, students use a learning system as a guideline to conduct the practical session with the absence of a demonstrator. In group work, students work in pairs in conducting the practical session.
Well, thank you, Mike. Talking about the plans around the ease of use of navigation, we look at three techniques or approaches that we'll use in this 3D environment. First is the instructional or intuitive approach. Basically, this kind of approach gives a step-by-step set of instructions to the user as he moves in the visual environment. It provides a general or application-specific constraints or manipulation aids. Ultimately, this provides a proper guide and enhances the ease of use. Secondly, we will use the mix of a naturalist approach with the magical approach. You may be asking yourself, what is that? Well, a virtual world enables a user to move beyond what is possible in the real world, so that utilizing a purely natural interaction metaphor may prevent many useful virtual reality applications that will not be possible in the real world. So instead, we opt to use a mixture of both the naturalist approach with a magical approach, which is an approach which is not based in a real world interaction. Lastly, we are going to use the direct and indirect approaches. In the direct approach, the user selects and manipulates objects in the virtual environment using simple mappings to some movements. For example, a hand movement. This is analogous to the way in which these actions are accomplished in the real world. Again, the assumption is that intuitive knowledge of the real world will allow the user to interact more efficiently. The indirect approach, on the other hand, allows the user to interact with the system using some intermediary widget or tools. This technique is analogous to the desktop interaction metaphor, where all the user input is mediated through the use of some simple widgets. Well, that's it from me. Thank you.
These are the 3D features for virtual chemistry laboratories. Virtual 3D manual that contains the practical details. A student will use this virtual manual as a guideline to conduct an experiment. It will contain methods, equipment, chemicals to use, and a report template whereby a student will write the results obtained after the experiment is conducted. The reaction conducted will be in 3D model, clearly showing the equipment used, the reactant. It will enable the objects to be viewed separately. The structure of each component, it will be demonstrated from all angles, clearly identifying the hydrogen's bond if necessary. 3D workstation equipment that allows our students to do their lab activities. The lab view will contain of 2 cupboards for chemical materials and equipment and a centered station to enable learners to engage in their lab activities.